We're going to take a look at simplifying radical expressions, and here I have two examples of radicals, in this case square roots. Well, you'd be very happy to see this one because the square root of 25 is 5, and you know that because 5 times 5 equals 25 works out perfectly. But what's the square root of 20? There's no number that times itself, actually there's no integer that times itself works out to be exactly 20, so I can't just plop down a 4 or a 6 over here. That means I have other work to do. That work could be putting it into the calculator and writing it as a decimal, which is fine in many cases, or the work could be simplifying radical expressions, and that's what we're going to work on this lesson, is how to turn the square root of 20 into a different radical expression. Before we get into how to do this, you should put on the top of a sheet of paper a list of the squares, or the perfect squares, and here's what I mean by that. Think of the counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and keep on going, but take each of those and square them. For example, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. You get the point. Well, this list of what I would call perfect squares is going to become valuable. And by the way, these perfect squares, these are the numbers that square root perfectly. Square root of 64, it's 8. Square root of 16, it's 4. So you'll see how we use this as we go through examples. And I've highlighted the original problem in blue and then written the answer. Like I said before, if you had square root of 16, no big deal, it's 4. But what the heck would you do with the square root of 75? So working with the square root of 75, the first thing you would tell yourself is, hey, 75 is not a perfect square. I have to go through this procedure. And this procedure is going to work this way. You look at your list of perfect squares and you ask yourself, and by the way, we're not going to use the 1. We're going to start at 2. Does 4 divide perfectly into 75? That's what you would ask yourself. And it turns out 4 doesn't divide perfectly into 75, so you go on to the next one. Does 9 divide evenly into 75? Well, 75 divided by 9 would give you some sort of decimal answer, so that's not going to work. 16 doesn't divide evenly into 75. How about 25? For the first time as I went up through this list, I found one of these highlighted yellow values that divides evenly into 75. In fact, it goes in there 3 times. So what I'm going to do is I'm going to rewrite square root of 75 using the 25 and then times 3. Well, why did I multiply by 3? Here's why. 25 divides into 75 3 times. If you don't like that explanation, think about it this way. Inside this square root is a 75. So 25 times 3 is 75. This is just a different way to write 75. So I've changed this into this by finding the perfect square that'll divide into there. And then from there, I call it 5 square roots of 3, and that's going to be my final answer. That's the reduced or simplified radical expression. Now, how did I get that? Here's what I said. Can I take the square root of 25? Yes, I can. It becomes a 5. So square root of 25 becomes a 5 on the outside. That's where that 5 came in. Can I take the square root of 3? No, it's not a perfect integer, so that remains in there. And by the way, this as your final answer is the same thing as this if I punch it into a calculator. If I do square root of 75 on the calculator, I get 8.66. Now I'll do the other one on the calculator. That's 5 square roots of 3 on the calculator. I also get 8.66. All right, let's do this procedure with about 2 more examples. The original problem is square root of 32. Square root of 32 doesn't work out perfectly to be an integer, so now I have to go through here And my job is to choose the largest one of these values that will divide evenly into 32. 4 divides into 32 evenly, but I suspect I can do better because watch what happens. 9 does not divide into 32, but 16 does. 25 doesn't, and 36 means we're already bigger than 32, so I can't do any of these numbers. So of all the numbers that would divide into 32 that are less than 32, this is the largest one that divides in there evenly. So I simply rewrite the square root of 32 as the 16 that I chose times 2. Remember, this 16 times 2 is just a different way to write 32. But the advantage of doing this is the 16 is a perfect square, so it's allowed to go to the outside of the radical as a 4. The 2 is not a perfect square, so it's stuck inside. And like I showed you before, if you punch square root of 32 into a calculator and 4 square roots of 2 into the calculator, you're going to get the same decimal answer. This is just a reduced form of that. Last example, 10 square roots of 54. Notice now that we have something on the outside of the radical. It's a coefficient, and we have a 54 on the inside. We're just going to ignore the 10 as we concentrate on the square root of 54. I go through this list. I'm looking for the largest number that divides into there evenly. I know I can't do 64 or above, so it comes from in this span. And in this case, I'll work downward. 49 does not divide evenly into 54, so I go to 36. That also does not divide evenly in. 25 doesn't divide evenly in. 16 does not divide evenly in, but you might be tempted and you might need to go to your calculator to try to divide it and see if it works. 9 does divide evenly into 54, so that's the largest perfect square. I rewrite the 54 as a 9 times 6. The advantage of doing that is the 9 is a perfect square, so it gets to go to the outside as a 3, because the square root of 9 is 3. Remember that 10? It just sits there. When the 3 comes to the outside, the 10 and the 3 multiply, and we get 30 square roots of 6 for a final answer. This is a reduced version of that. And that is simplifying radical expressions. In this case, we have no variable expressions, but you'll find out later on in your math life that you can put variables in there as well.